departments. Just on behalf of my director, I am presenting this. I'm presenting.
Yeah, good
Uh,
morning. Yeah, am I
yeah,
audible?
yes, sir. Yes, sir. No,
Yeah,
my
good
director.
morning, madam. Good morning, Sharma Sahab and the organizers. As you know very well that Telangana state is the recently formed state, and there are many challenges in the water sector, and for which our honorable chief minister, under the chief ministership of our honorable chief minister KCR Garu, we are taking this to the higher level in the water. It means the irrigation sector has been improved a lot, and now the groundwater contributes about 65% to the irrigation sector in the state and almost 10% to its GDP. So in that connections, actually the groundwater department is mainly engaged with monitoring of water levels, water quality, as well as the groundwater estimations, and we carry out a lot of other works, implementation of the Volta Act, all those things. So in this connection, actually, we are monitoring a lot of monitoring wells from all over the state, where the density of monitoring wells is around 55 wells, 55 per square kilometer per well. So we are monitoring since 50 years. We are monitoring the water level data. So how we have improved in the water level monitoring, and how we are disseminating the data to the state virus as well as to the national virus system, and ultimately to the water information management system of the government of India. Now I request my in charge officer, that is Dr. Mahesh, to present the case and for the jury for their evaluation. Thank you once again, madam and sir.
Thank you, sir.
Yeah, I will
Thank
be
you.
available. I will be available.
Thank you, sir. Thank
Thank
you
you.
very much. So I am going to present the saga of monitoring and analysis of groundwater data of the state in my coming present and in my future slides. Like in many countries, groundwater is the one of the major resource for different users in the Telangana state. So hence it must be managed and protected carefully to enable the most beneficial use of it. So directly coming to the point, the challenges in the challenges in groundwater sector domain is that to characterize a regional groundwater system, the first thing, and then identifying the groundwater trends with respect to the time, whether it is increasing or decreasing, and also identifying the potential zones, and also quantify the regional impacts on stresses on the groundwater stream. Also, to assess the contamination that may be anthropogenic or geogenic contamination in the groundwater sector. Also, to assess the impact of groundwater management measures. Also, to have the baseline data for newly proposed projects. These all are challenges in groundwater domain. But the single answer is that without monitoring, we cannot do we cannot attempt anything. So this is about the monitoring of groundwater. It's an effort to obtain the quantitative information on of the groundwater regime. The primary objective is to establish monitoring networks and also record the response of groundwater regime to natural and anthropogenic stresses. The data so developed will be used for reference purpose and prediction measures, and also an estimation of the resources, and to have the environmental controls. Coming to the state observation monitoring network, even though the department is observing the groundwater levels from last 50 years, but from 2000 onwards, we have constructed a dedicated purpose-built observation well network. In the phased manner, we have increased it. Uh, So presently, we have 53 square kilometers per one well. Means one well for the 53 square kilometers. It has come down from around 250 square kilometers earlier. And coming to the observation monitoring workflow, the data, primarily the field officers from the district officers will collect the primary data, and they collect the water level data. Also, they collect the water samples for water analysis. They collect and they do primary validations at the field level, and they submit that data to the state data center at the head office level, state level. In the state level, the entire data from all 33 districts will be subjected to the secondary validation and also processing of that data in the form of maps, generation of the maps, analysis, everything. And in the state level, we are generating the monthly groundwater level report. This report is disseminating to all line departments as well as administrators. All administrators, also the common people through print media and other electronic media. Also, finally, this data is being shared to dashboards, decision support systems at state level like Telangana Water Resources Information System. Also in the national level, India varies. Also through our websites, we are disseminating the data. So, so the methodology, because it's a vast subject and it's a scientific approach. So the methodology which for analyzing this we adopted. So in my these are the 7 methods we have standardized to analyze our groundwater levels to know to get the meaningful results. So the first thing is we will compare. This is compare the groundwater level with the rainfall and its intensity. Also, groundwater behavior with different geological formations in the state. Also, monthly observations for what is whether it is gone down or whether it is gone up, like that analysis. Also, season wise, pre monsoon, post monsoon, annual, also decadal. So, like that, we have um, um, standardized some methodologies to analyze so that the results can be understandable to common and scientific community. So this is monthly average groundwater level and rainfall. So the graph showing the rainfall versus groundwater level. Definitely, the rainfall is a principal source for the groundwater recharge. So the groundwater levels in proportion to the groundwater rainfall will behaves. So if we observe in the top graph, whenever we are getting the state getting the deficient rainfall, means it's less than normal rainfall, we are experiencing the deeper water table, which is uh, showing in the way below the graph below. So whenever the state is experiencing the less rainfall, deficient rainfall, the state is experiencing with the deepest water levels. And also, as I said, the groundwater movement will be different in different geological units. So we are also monitoring this fluctuation of groundwater with respect to their formation. In the state, we have around 13 geological formations. So formation wise, also we are analyzing the data so that in which geological unit is behaving good and bad or something, how it is fluctuating. So that is also we are monitoring, we are analyzing. Coming to the monthly, the deepest water level will be in the pre-monsoon. That is in the May in the month. From June, the monsoon starts. So the deepest water levels are being replaced by the shallowest because of the rainfall. So how this water levels are fluctuating monthly, we are analyzing during the monsoon as well as the non-monsoon. After the monsoon, from the December, the water levels come up and again it goes down because in the non-monsoons. What is the trends and how it is behaving? That monthly we are uh, observing, we are analyzing. In the same way, annual. If we observe in the last, in the two graphs, in the May 20 and May 21, in the year 1920, we have received 1033, which is 14% more than normal rainfall. But the area, the state area, which is having groundwater levels less than 10 meters, is occupied by 48%. This is 6 and 42. This graph is showing the area of state occupying by shallow water levels, that is 5 meters, and this is 10 meters. If we see consolidatedly, I see 48% of the state is occupied by 10 less than 10 meters of groundwater levels. Well, coming to the next year, that is 2020 and 21, the water rainfall is more 46% excess. So it has increased to 68%. Means most of the more than 50% is water level is having less than 10 meters. So this type of analysis will give a clear idea about the groundwater levels in the state. And second, monsoon. Apart from the monthly, we also analyze to pre-monsoon and post-monsoon seasons. In the same way, the deeper patches in the pre-monsoon is reduced in the post-monsoon because of the recharge and other rainfall. And in the same way, because of the draft in non-monsoon season, and this again the red patches are appearing, and the blue patches, shallow water levels are going up. And also, apart from this, we are also comparing this water levels, present water levels, the decadal mean. For example, for the July month, the present year, with the mean of all 10 years July. So we can able to, because of this analysis and this comparison, we can able to identify the pockets where we are having the groundwater levels are increasing and where we are water levels are decreasing. In the right side figure, I can say directly the blue patches are the entire area covering with the blue hatching is in rising trend, whereas the red patches are showing the decreasing trend. So water levels are going down there. So based on this all analysis, subject to the statistical interpolation and representations, graphical representations, we have simplified this groundwater science so that a common man or non-scientific community or any administrator or any political representative or politician and public representative can understand what is happening, because what is happening in their area, and we have made it simplified to all non-scientific community also based on this standardized procedures. And also, we are also estimating the groundwater resources monthly basis. Means if the state is experiencing as a state average, groundwater level average is fluctuation is 1 meter, what may be the available of groundwater in the subsurface. See, based on this model, if the state is experiencing 1 meter of fluctuation rising, so around 100 TMC will be available water. In the likewise, if water has gone down to minus 1 meter, so there is a deficit, mean draft of 100 meters on 100 TMC. So we have also developed one model to predict the groundwater availability in the subsurface.
Sir, could you please conclude your presentation in next 2 minutes?
Yes, ma'am. So in the same way, this methodology is used for command and non-command areas in the command areas in the state, major command areas in and urban areas. So as an outcome, so we are preparing monthly water levels, and we are preparing reports, charts, maps, and we are communicating, disseminating this data to the common public as well as the line departments and in national varies and state varies through print and electronic media. As a result, we are able to now find out the declining water level trends, also deeper water level trends, and where the water logging conditions are there. Also, the potable and non-potable quality of in the groundwater. So, based on the standardized methodology, in every month we are able to watch this groundwater in the state. Thank you, sir. Hello. Thank you, sir. Now, any questions?
Quite interesting. You are using technology.
Yes, ma'am.
But how accurate is your measurement? Like you are delineating the water levels for potable water or non-potable or whatever. So the question is, if somebody wants to dig a borehole, you are saying that you are also disseminating to the public, not
Yes,
to the
ma'am.
government, also to the citizens. So if somebody wants to dig a borewell, with permission, of course, and want to find out a place in his land, so how accurate is your the estimations are? Like borewell will be a very small parcel of land.
Yes, ma'am.
Okay, so like in the early days, we used to use a person who will come do some kind of calculation, the oral traditional methods, and will tell a place that this is where you dig and you'll get water. We know that's not scientific. Yours is more scientific. So how accurate can you predict that?
Sir, for digging the bore well, if any groundwater scientist, means from any groundwater department, do some survey, that survey will be accurate up to 70 to 80%, madam. As per the scientific investigations. Yes, ma'am.
No?
Yes.
That kind of failure could be there. I'm saying, what is the size, accuracy in terms of meters or maybe centimeters or whatever? Because when you are digging a borewell in a parcel of land for personal consumption, you don't have acres and acres of land, So how accurate you are within that boundary of a person who may be owning, say, maybe half an acre of land or whatever?
So the availability means the success of the borewell depends on our experiment, madam. But the availability will occupies the area, means the extent of area, means the availability for 1 acre, definitely availability of groundwater in 1 acre definitely multiplies with in 10 acres, means if compare 1 acre to the 10 acres, so per 1 acre people is having 1 meter, and 10 acres will have the more available water, because the water
No, sorry. So let me put it separately. Like previously, I used to go to somebody who will tell me where I should dig. Will put a cross that this is where you dig and you will get water. Now that you have got delineated land, that this is potable water, this is the depth, this is the water table, and all that.
Yes.
How accurately you can predict that if I dig the borewell, dig it for my borewell at this particular point of time, a place, then I will get potable water as per your table. So that point, how accurate is that? Do you say that if I do it within the 10-meter radius, I will get water, or you say 1 meter radius, I'll get the water? What is the accuracy of your delineation?
Can I supplement, madam?
Yeah,
yes, sir.
Yeah, madam. For this, actually, my department, we are having it is a multidisciplinary department consisting of hydrogeologists, geophysicists, and hydrologists. So when we wanted to do any type of investigation, so we do with the first of all, we pinpoint the site broadly based upon the hydrological investigation carried out by my scientific officer, a hydrogeologist in that particular district. And after pinpointing some particular site, 2-3 sites where one wants to drill a borewell or construct a tube well. So there again we will do the geophysical survey to decipher the subsurface geology. So there we carry out the geophysical surveys and we pinpoint the site, and we can know at what depth we can get the aquifer, or what is the strata below subsurface. So based upon that, what our experience says that the success rate of getting the water is about 80 to 85% when we carry out the surveys. In particularly this Telangana state, as you know that Telangana is mostly covered by the hard rock aquifer, so it is very so 10% maybe variations may be there, but it depends upon the experienced field geologist or field geophysicist who is carrying out that survey in that particular area. So but, as my experience says that about 80% of the success rate is there in our state if the expert hydrogeologist or geophysicist carries out the surveys in at that particular point. Yeah, this is what I want.
You mean to say? So you mean to say?
Yeah, madam.
Yeah. No. So you mean to say that if somebody wants to know whether there is water in this particular place or not, the
yes, 80% success. 80% success.
A fresh survey has to be done by your geologist, hydrologist.
Yes, exactly.
I'm not asking that question. My question is different. I said that you have drawn these delineated areas with water table, right? You already have drawn maps.
Yeah.
Right. You already have drawn maps. I'm not saying if for every single borewell digging, your geologist has to go or hydrologist has to go. It's a very cumbersome process, as well as the time taking and cost also is there. I'm not asking that. I'm saying in general, for the whole state, you have delineated areas with the water table, potable water, and all these different qualities and all that. My question is how reliable that map is.
Yeah, that's actually definitely, because as per the present density, as I have said, that the present density of our wells, monitoring wells, is 53 wells per square, one well in 53 square kilometer, which is far ahead than the national average, where it is more than 100 square kilometer per well, as per the CGWB data is there. But in the my state, it is about 53 square kilometer per well. We are having more reliable data, and we have established telemetry also. We are having the digital water level recorders. So where we are getting the precise water level data at the hour of 6-hourly basis, also we are getting the water level data. So based upon that, these are the some estimations, because in getting hard rock areas, definitely there may be, definitely I agree that there will be variation, but based upon the present, up to some extent we are sector, because it is an invisible source. So definitely there will be always scope for improvement. So again, we are in the process of improving our monitoring network, we are implementing national hydrology project, main aim of this project is to improve the density, as well as the water density of monitoring network for water levels as well as the water quality.
Okay, thank you.
Based, ma'am, just want to add, based on our maps, our delineation, we can say more than 70%, ma'am.
Okay, thank you.
Thank you.
Mr. Mahesh Kumar, I think in an area which you find that water level is not up to the mark, then do you also resort to creation of water bodies to raise the water level?
Yes, sir. Yes, sir. We suggest to the government for remedial measures.
Mahesh, let me just reply to Dr. Sharma sir's point. Actually, yes, sir. We have identified wherever the water table is deep, based upon our water level trend data of the last 10 years. We have taken up a lot of water conservation measures. That is your supply side interventions we have taken up. Like we have identified the area where the water levels are deep, and your extraction is also quite high. So we have proposed the construction of major check dams, as well as the recharge injection borewells in the existing minor check dams also, or percolation tanks also there, so that whenever the rainfall is coming, or during the monsoon season, so we are taken up a lot of recharge shaft or injection wells in those areas. So there also we are improving. If you see the last 10 years average water level area, particularly the western Telangana area, the area of the deeper water level is reducing because of all these supply side measures. And Mission Kakti also, our government has taken a lot of tanks rejuvenation under Mission Kaktiya. So that is also helping to recharge the aquifer. Yes, sir.
Okay.
Definitely,
Okay.
we are
Thank
improving
you.
in.
Thank you, sir.
Thank you.
Got
Thank
it.
you, Sharma sir. Thank you, sir.
Thank you, sir. Thank you very much.